All right, so I have a problem I want to do. All right, and you'll see when we do this problem that I've actually given you guys some stuff that you don't have to write. Like, for example, we're talking about two chains and how they make their pizzas. Nice. And we're looking at the saturated fat content in these pizzas. So I have Domino's, brand D, and Pizza Hut, brand PH. So these numbers here are for individual pizzas and their saturated fat content. And I've already written down this right here. And what is this called?
Parameter.
Very good. So this is defining the parameter. Okay? So right here, I've already defined the parameter. Now, you'll notice that I wrote out mu, but I would not write mu. I would actually just do the symbol. Okay? So when you write it down, you would use mu, but it's already there. You don't need to write it down. Okay? So if you're going to use the yellow calculators, all right, now would be the time to hit data and type in your data values into list 1 and list 2. So remember yesterday you guys asked me about the Homer problem about should it be 2 or 1 list? So I think you're asking about this. I had you put it all in one list. But in this case, we have 2 different groups. So I need you to put all the numbers for Domino's in one list, and then all the numbers for Pizza Hut in a second list. All right. Personally, I like to use Desmos, so I'll show you what I did in my free period to prep. All right. You'll notice that I put Domino's as D and Pizza Hut as P with Desmos. All right? Does everyone see that?
Yes, sir.
Okay, so before we get into kind of using what I have written down, let's go ahead and make our hypotheses. So, what am I going to put for the null hypothesis? What do I always assume for the null hypothesis? I'm looking at these two different brands. Mu, I'm going to do mu sub D minus mu sub pH. Okay? Equals 0. Now, you could also write, I think I heard Leslie over there, you were saying you could do this one, mu sub D equals mu sub pH. These are the same thing, right? I like to put subtraction, like I showed you with proportions, because when you do your actual mechanics, you're going to subtract them. So I'm just kind of helping your brain get there. But if you want to use how I did it in green up here, that's fine. You can just write mu sub D equals mu sub pH. Questions on the null? Okay? Ooh. What about the alternative? What am I going to write for the alternative? Mu sub D minus mu sub pH. Anything in the problem that tells you what I should use, less than, greater than, or not equal to? Why do you say less than?
Because there's less samples for Pizza Hut.
Interesting. There is a smaller sample of Pizza Hut. That doesn't have anything to do with the symbol I use, Bianca, but we can talk about that it actually is a smaller sample. Really? No? Why do you say not equal to? Different, right? Different. All it says is different. It doesn't say one might be more or less. It says different. So I'm going to use not equal to. All right? Now, Bianca actually pointed out something interesting we're going to get to later, but I'll bring it up now since she saw it, is that the sample sizes are different. Guys, that's not a problem. All right? That is not a problem for doing a 2-sample t-test. It's all good, even if your sample sizes are different. We're going to talk next week about something called a paired t-test, where you're going to notice the sample sizes got to be the same. Okay? But for now, all good that they're different. All right, let's go do the assumptions and conditions. Yes, Leslie, I'm sorry. Oh, with the green one. My bad. My bad. Same thing, just not equal to. Your choice. Again, I don't care. Whatever you'd like. All right? Okay. Now, I made a quick mistake, so I'm sorry. But if you look at the next 2 slides, right, you've got one on this page, and if you flip over, there's another blank one. I forgot to move this. So this statement should actually be on the next one. Everyone see that? See what I'm saying? because I'm not done with my assumptions and conditions yet. So let's go ahead and get started, though. What is the first assumption I'm going to make? Independence. Okay, who wants to give it a try? All right, not all at once. Yes. Ooh, interesting, Catherine. I bet I can get away with this and with one sentence, but yeah, you got to mention both because we've got two groups now. I think the sentence I could do to get away with it is, go.
The average fat content of Domino's pizzas will not affect pizza Hut.
Okay, so what you actually are saying is another assumption. That's going to come at the very end called the independent groups assumption. So your statement is great, Leslie, but it's really more at the end when you ask, are the groups different or independent? Okay, so we're going to come back to that. What I would say is any pizza's fat content does not affect another pizza's fat content.
You have to say like at both.
You could say at both chains. All right, you can say, man, let's try to make it a little more condensed. Let's say both chains' pizza's fat contents are independent of the other pizzas they make. Something like that. Yeah, let's go with the first one. Bianca, what was it?
One pizza's fat content is not affect another pizza's fat content.
You got it. At both restaurants, at both chains. Basically, what your brain wants to do here is right now you're thinking of them as separate restaurants. So you're saying, okay, if I go to Domino's and I look at pizzas that they make and look at the fat content, it's going to be independent each pizza I check. All right, same thing if I were to go to Pizza Hut. Right now we're going to each. What Leslie said earlier was saying, okay, now if I look at them together, do I think that they're independent? And I have no reason to believe they're not, right? They're completely different chains. Okay, let's talk about some conditions we're going to look at. Let's do the randomization condition. Does it say anything about a random sample? Let's see. It does not. Sad. So remember to use that kind of catch-all statement that these sample sizes of pizzas are a good representation for all the pizzas they make. Right? I'm assuming how they made these pizzas is how they make all their pizzas. Sure. So basically when I think about the randomization condition, Daisy, if I don't see anything about a random sample, then I have to make a claim that this sample is representative of all of the pizzas. That's ultimately what we're trying to say. That when we make conclusions based on this sample, we feel confident because it's just like any other sample. Now, what about the 10% condition? You got to do both. Very good. So what's the sample size for Domino's? How many pizzas are we looking at from Domino's? 20. Very good. All right, so if I multiply that by 10, I get 200. Does Domino's make more than 200 pizzas? Yes. Absolutely. In my life, I'm sure I've eaten more than 200 Domino's pizzas. That's probably accurate, actually. What? I mean, when I was in college, we used to order, everyone would get their own pizza. You know, like you get like 5 mediums for like $5.99 or something. Let's eat it all. $5.99. It's college, man. No judge. Okay. Yeah, they still have that deal, I think, where you get like a... Yeah, it's like, you can get 2 for $5.99. Oh, it used to be you could get, yeah, you just get as many as you want.
Are you serious?
Now you know. Tell them I sent you. Okay. Now, Pizza Hut is a different story. I'm not a huge Pizza Hut fan. But that's okay. It's all good. Just too greasy for me. There's 15 of them. Okay, that's why I get extra sauce. So 150. Does Pizza Hut make more than 150? Okay. All right. Let's go over to the other assumption. This is the normal population assumption. Now, this statement is basically saying that if I were to look at all of the saturated fat content for every pizza made by each of these, okay? And they show me the histogram. That histogram better look what? Unimodal and symmetric. This one, it better be perfect, right? Because I'm assuming it's normal, okay? So again, I'll repeat that. If I were to look at all the pizzas that Domino's and Pizza Hut have ever made and their saturated fat content, then the histogram better be unimodal and symmetric. That's what I'm assuming. Now, do I know that, right? Do I have all of the pizza data values for these chains? I don't, but I have samples. So we check a condition called the nearly normal condition. And this is where you're going to actually make a histogram. Now, I've already done this, okay? This is why I prefer Desmos, right? When in Desmos, I put my data values in for D for Domino's and P for Pizza Hut. So you see I have histograms here. So here's Domino's. Okay, here's the Domino's histogram. What do you guys think? That's just Domino's.
Wait,
Time out. 30-second or full, Coach? Okay, go.
what link is the link that we have to use, or just the link that you use?
No, I mean, that's not really, I just type in desmos.com. You're good. We did this in maybe September, Daisy, like where I put them in brackets.
Yeah, we probably saved it.
Yeah, and then histogram, there's a video out there of it, and then histogram of that variable. And you see my comma too, that's the bin width. So I just changed that number until it looks like this. Okay. Guillermo, we good? Okay. So do you guys think this is unimodal and roughly symmetric?
Yes.
I think so too. So I feel fine with that. What about, here's Pizza Hut. I hear people groaning. Man, whoa. Oh, I hate the color green. What's wrong? Why are you groaning?
What's wrong with green?
I'm just joking.
Yeah, drink some.
Maybe some skewness. Okay, so if you think that there's some possible skewness here, what do I have to say when I'm doing my work? They're possibly showing some skewness. And what do you think about the sample size of 15? Is that small or big? That's small, right? So I'm a little bit worried about this. Obviously, since this is a problem, I'm going to keep going, but I'm going to make a note that the histogram, I'm going to sketch it. They can see this histogram is showing skewness, so I'm a little bit worried about using our T model for this histogram.
So what do we write?
What I just said.
Oh, okay.
Basically, you just want to make a note, Catherine, that says, hey, here are the histograms. Domino's one, remember the Domino's one? You guys loved that one, right? You guys had no problem with this one. Unimodal, roughly symmetric, boom. But Pizza Hut, you guys have groaned about it because it was showing some possible skewness to the right. So we just need to make a note. Like, hey, if you're reading my work, I'm making a note that I'm a little worried about this skewness in this histogram. Please, yeah. I mean, if this is, and that's why you have another slide. If you want to use the slide after, you've got more room. Okay, my bad. Again, I don't need it to be a beautiful drawing, something that takes no more than 30 seconds to sketch. The whole point here, guys, is you want to check this. You just got to check it, right? Because if you're not checking, you're not doing your due diligence. Should I go to Pizza Hut? Okay, sorry. I thought you wanted Pizza Hut. Did you already sketch it? Okay, you already got that one. My bad, Bianca. Sorry. People in the Midwest loved it. Whenever we would order, all my friends in college that were from the Midwest, they'd order Papa John's. And I'd be like, Domino's? Please. We used to have arguments all the time about what we're going to order for the Super Bowl. All right. Yeah. Yeah, skewness. Oh, whatever the tail is going, right? Tail, so to the right. Skew to the right. Yeah. Okay, let's do the very last one that Leslie actually, you said first. Remember that? She said the independent groups assumption. So this one, all you need is one sentence that you are assuming that the saturated fat content in Domino's pizzas is independent or doesn't affect the saturated fat content for Pizza Hut pizzas. All right, so again, a statement that says your pizzas from one chain and their fat content do not affect the other chain's pizzas and their fat content. Okay? Yeah, you're going to have to write this down, right? I'm obviously taking the teacher card of nope, but you are not a teacher yet, so you got to write it down. Maybe you'll get lucky and I'll say, oh yeah, just go ahead and assume that all the conditions are satisfied. Maybe. Okay. Now, I told you guys that if you wanted to use the yellow calculators, you'd have to put these numbers into list 1 and list 2. All right? But I like Desmos, and I already took the time to put them in, so I'm just going to ask Desmos to tell me the mean and standard deviation for each of these groups. So I'm going to do the mean of D. Well, no, I'm not. Where'd you go? Oh, yeah, he's capital D, Douglas. Silly man. There we go. Okay, so I'm telling Desmos, give me the mean of those data values for Domino's. So it's 11.25. So do you guys see the slide that says mechanics?
Yeah.
So on the mechanics slide is where I'm going to put all this. 25. So I have Y bar for Domino's is 11.25 grams. Okay? Then, in terms of the standard deviation, okay? Put this on so it doesn't do that. For standard deviation, I'm going to type in STDEV of D and get 3.19. Everybody good? Okay, and how many pizzas? The sample size? How many pizzas? 20 pizzas. Good. I'm going to do the same thing, but for the Pizza Hut. So I'm going to type in. Actually, you know what I'm going to do is where it says D, I'm just going to change that to B. P. See that? Does that would save a little time? There we go. All right. There are shortcuts. I just used it. All right. So the mean for the Pizza Hut is 6.53. So Y bar Pizza Hut 6.53. You did. It's on my desk. And then this standard deviation is on my desk. The standard deviation. I'm recording. Jeez, Jennifer. The standard deviation for Pizza Hut is 2.59. And how many pizzas? 15. Okay. So again, for the test, obviously you'll have the yellow calculators if you want to do that, or you can use Desmos. That's fine. It's up to you. All right. So let's go ahead and do the actual math here, the mechanics. So here's the formula. You ready? So it's T with a degrees of freedom I don't know yet. Right? Have we calculated that yet? No, we haven't. So I don't know what it is yet. Equals the difference between these two sample means minus, in this case, 0, because I thought they had no difference, over the standard error of Y bar Domino's minus Y bar Pizza Hut. Okay? So let's plug in the values. What is the mean saturated fat content for Domino's? Very good, 11.25. Minus, what is the mean saturated fat content for Pizza Hut? 6.53. All right, and I'm going to write the minus 0, but you know subtracting 0 is nothing. Okay? Over, and this is the formula here, the square root of, you're going to put the standard deviation for Domino's squared. So put 3.19 squared over the sample size. And the sample size for Domino's was 20 pizzas. Plus the same thing for Pizza Hut. 2.59 squared over 15 pizzas. 15 pizzas? Yeah, I mean, that would be a lot. Okay? Now, when you get here, we're going to go to the internet. All right? We're going to go to MathCracker to have us, it's going to tell us what that t-value is. And it's also going to give us the degrees of freedom. Okay? So if you go to the email I sent you guys on February 26th, all right, and don't worry, before we take the test, I'll post the links onto Classroom again. But if you go to inference for means unit links, you've got all 5 links you need. Which one are we going to use? 2 sample running a test, 2 sample t-test. All right, so what is our null hypothesis symbol? Equals. What about our alternative? Not equals. Okay, the sample mean for the first group, that's Domino's. So that's 11.25. For Pizza Hut, it was, I forgot, 6.53. Okay, the standard deviation for Domino's was 3.19, and for Pizza Hut was 2.59. The sample size for Domino's was 20, and for Pizza Hut, 15. You can put whatever you want for the alpha. I think I wrote in my notes for you guys using an alpha of 0.1, whatever, 0.05. It doesn't matter. You're going to see this p-value is tiny. So let's just do 0.05 because you guys are used to it. All right, now here's something new. Does everyone see how it says assume equal variances and it has a little dot next to it? Well, we can't assume that. Okay? We cannot assume that the variance of these two groups is equal. So actually what you're going to do for this is pick the middle one where it says assume unequal variances. So make sure this is something new. You've never done this. Make sure that that dot is clicked for assume unequal variances. It is a 2 sample t-test. T-test for 2 means, yes. And hit solve. Yeah, let's go! Stay.
No more ads. No more ads.
Yeah, it's currently blocking 3 ads. Thanks, Wences.
Yeah.
Appreciate it.
You open up YouTube, somebody's gonna say like 1,000 something.
Is it really? Oh my gosh. All right, here we go. Now, what I first want to do is I first want to show you that it gives you the degrees of freedom. Does everyone see that? So I have to actually go back in my work and type in the degrees of freedom of 32.75. So I'm going to go back here, erase that, put 32.75. And I know I didn't mention this before, so I apologize. But I left a blank here on the statement where it says with blank degrees of freedom. So that'll be the 32.75. Okay? So make sure that you kind of go back and fill in the blanks because I have to use technology to tell me the degrees of freedom. Okay? All right. So what is my t-value? Let's see. Our t-value is 4.827. You guys see the blank slide after that? Let's draw our curve. 4.827 is way out there. And we're shading actually both tails. All right, so what is the p-value? My p-value is, it says 0, but I think, does it give me an actual p-value? Oh man, I guess it's 0, okay. When I did it last year with like a graphing calculator, it was I think 4 zeros and then a 3, so basically 0. So we'll say 0. Okay guys, p-value of nothing is obviously going to be below our alpha. So what are we going to conclude? Reject what?
No.
Very good. You're going to reject the null. The p-value is small, it's 0. So we have reason to believe, we have enough evidence, that the difference in saturated fat content is not 0. All right, that there is a difference between the fat content in Domino's and Pizza Hut. So I actually wrote the conclusion for you. Yeah, I was right. 1, 2, 3, 4. Awesome. You can write if you want, but yeah.
What was your degrees?
Degrees of freedom was 32.75. It's right here in the math packer. The first time I think they say it is in number 2, degrees of freedom. And again, Bianca, it's going to be one of those things where it's kind of weird. You're going to do all this work, but kind of have to go back to write down the degrees of freedom. Okay, who has any questions about running this test?